So right now you don't have Anaconda environment. Okay. So to load the Conda environment, you need to do like the module load. So this is the command I already copied here for you. So I'm using this one. If you want to use anything else, you can use. So module.
Should I use a newest one, do you think, or should I
Generally newest is better.
Newest is better? Okay.
So 5 is the newest one. So you load this one and you have Anaconda in your thing. Okay. Now you have Anaconda and now you can create your own environment. Like contact your environment and install all the packages you need, all this stuff. And like just you get whenever you get in, you can do contact activate your environment.
Okay. Then I can also use Git, right? I have to install it as well.
Which one?
Git, Git.
No, Git is already there. It should be already there. Okay. So Git already comes with the system.
Have you ever played with Git large file system?
No, I didn't. We didn't go there yet. So now you have Anaconda and you can install stuff. Once you have once you have all the things you need, the third step is to basically go then run, and the third step is basically run PBS script. Okay, so this I will show you the PBS script what I have. So Louis use this one.
What is that clear command? What does that clear command do?
Which one?
Clear.
Clear screen.
Everything. Okay.
Then we have this CMA. I don't know what it is. Okay. So copy. I can copy here. So nothing. Copy users VJ. What is it? Use CMA single GPU to single core VJs. Clear home. So these are the basically two scripts we ever used in our research. So we are also kind of new to this one, so we didn't use much, but these are the two main important things that you need. If you see the files here, you can see the files. So you generally use Emacs or like VI. Okay, you have to know either of those things. Or every time you want to change something, you change it in your local and then push using SCP. They say so the SCP is good to push like first time, and then they have something on rsync. This one is better because every time you change something, it always going to sync those things. It won't push everything. So people say rsync is better once you have all the files there. Okay. It's like you can say.
Okay.
So you can see single code. So just like go through these things. So the main things are these ones. Okay, so here basically I'll try to explain you what is happening. So here you are requesting a single GPU. So in Xena you have four types of systems. One is system with single GPU, another one is system with dual GPU, another one is a system with no GPU but 1 terabyte of RAM, another one is a system with no GPU 3 terabytes of RAM.
Okay.
So like if your RAM is important, then use that. Okay. And each system, like each node, one system is called a node in their language, has a 16-thread processor. So if you don't mention PBN 16 here, what is going to happen is the scheduler will schedule other people's job in your system. If you use only 8, it thinks yours is free and schedules your jobs. So always use 16 so that one node is completely for you.
Okay.
Otherwise some data will mess up later. Okay, that one. And wall time is basically you are requesting them 20 hours of time to run your stuff. Then the maximum is 48.
48.
Okay. If you need to run more than 48, you need to request through Marios that you need to run more than 48. Okay. And like your home folder will have 100 gigabytes of memory. maximum. If you need to extend, you again need to petition. They'll give you 200. That's the max hard limit. Then don't go like before. This is basically the name of your run. So when you run, when you do Q state, it's going to show this. I will show you what this one is. And basically you are using bash, and these are the most important modules that you need to do. So in this case, Luis is using OpenCV, GCC, Anaconda, this one, and he is activating his environment. In your case, if you are using only Python, all you need is these three. Don't need of these things. These are related to OpenCV 4.1 and all this stuff. Okay. So once you have these things, you basically write commands like you write in Linux. So this is very important. Never skip this one. It basically says change directly to your current, where the PBS script is. Okay. Always keep the PBS script inside the folder which contains the script where you run like all your stuff. Okay. You have like 100 different files, but you run one file and it's going to run all the 100 files. You keep the PBS script in the place where you have the one file which runs everything. Okay. Okay. And this is basically echo. It shows like when you start, and this is your command. In Luis' case, it is like the iterations test one. Once you finish, this is it. Okay. So the thing is, once you are done, it's going to output two different files. One is error file. So E is for error file, and there is an output file. O is for output file. Error file is basically you have some system errors or something, then you get it in the error file. Output file is all the print statements you keep in the program. Those are will be the output files. Okay. Okay. Try to run like a very simple examples first and see like how it is working, and then you can go further.
So the PBS is going to be this one or both? Or
so this one is basically an example of a single core. So instead of single core, if you want like a dual GPU, you basically do here dual or something, dual GPU.
Okay. So and this is the file that I'm gonna have in the same folder of where everything's gonna run.
Yeah. Mainly, like, I can show you a simple example. Okay. So the first thing is you need to install the environment. Okay. So I'm going to just install some random environment.
If you want, you can. I'm gonna use this one, so you can do Conda create
My
TF doesn't use TensorFlow,
TF,
and then I space TensorFlow.
Okay. I think it is like this. I think here like
I think it's gonna create name. Yes, it's like that. Okay. And then TensorFlow without the R.
was that.
Shit, I don't know. It's gonna take too long.
No. Generally, the thing is, we don't know. Depends on number of users. So these are like our not our personal computers. So if there are 3 more people logged into the same machine and trying to copy stuff, it will be slow. If there is no one, they are very fast.
Oh, I see.
So it's fast. The thing is, here download is very fast, but the thing that is slow is writing. So they need to write to hardwares. These hardwares are RAID 2, RAID 3, something like that.
Okay.
That will not take time. They have very fast internet. So what I can do is, I can actually write a bash script so that it automatically loads your environment every time you log in. So this is
Have you? Do you use Ubuntu, right?
I used everything.
Yes.
Linux is something like a hobby for me, so I keep installing a lot of things.
Like all the okay.
So this one right now has a Debian inside. So MATLAB is not working, so I had to go back to Windows. They have some license problem. Windows, the MP4 video files work with Windows. They don't work in Ubuntu. I don't know if they changed it, but like it didn't open, so I'm going to test here and then go back.
For when you are in Canada, huh? Nice. Yes, so yeah, I asked you about Git LFS, like the large file system, because the project that I'm trying to understand is using that one. But I don't know how to use it. I mean, I've been reading about it.
And it's like recent one, like 1 year back.
Really?
Dallas Bus, I think so. It became famous after the big data revolution. I mean, like I am supposed to use it, but like after that, I didn't upload the files. Everyone told to use that one. I mean, if you try to upload your files, which are like 1 gigabyte, it will actually tell you to use it. Otherwise, it won't upload. It won't be hard. Trust me.
Shouldn't be hard.
Shouldn't be hard. I mean, these things are given so that the programmers have ease of life. They're not made to make your life complicated. So they should be easy. So this is extra. How it looks. So choose tab basically shows who is running in that machine. Right now this guy is running. Okay. Choose tab and like choose tab minus f basically gives all the information about this guy. Like how much work time he did and everything. Anyone can see your stuff, but they cannot edit your things. So this guy is running on. There should be a system name here. Server is single GPU. Okay. There should be a number somewhere. Which is the ID. And he should be like Xena 9 or Xena 15, something like that. So all this information will be useful for you later. Yeah, it's done. So, so let me add like this is a bash script. So this is the these things are important. Okay, I'm going to write it here like written by wages, so that if you want to change it, you change it. Instead of this one,
So that means that every time. Okay, so.
haha.
You
to really ask them to change your password. They have a command. I forgot of that command.
X.
So now it's going to load your environment by default.
Oh.
So now you have Python 2.7.
Ah, shit.
You should have mentioned 3.
I need to update it.
You can change later, you know how to change all these different. So let me go to this one. And I need to change this one. This one. Okay, so copy. So what is it? Previous script and simple core stuff, and you go to here. Okay, so now I have this one, right? So Emacs, single core VBS. So here you need to like everything will be the same except for instead of this one you have TF. Okay, TF, and instead of this guy you have Python. What's the name? You remember the name?
Oh.
Print lala. So now you have this choose sub, and you do single core.pbs. That's it. Okay, yours should be running. Should you use that? So this is your username. This is the name of that one, and yours is in queue. And now it's running. It will be done fast. So if you want to continuously watch queue step. Okay. So now you can see every 2 seconds it's going to get updated.
Update. Okay.
So yours is done. Once you need to come out of this one, you do Control C. Okay. So now you see you have like error file or
Okay.
okay. That's the error file. There is nothing in the error file. Output file. You have the Lama. Job started at this one, went to Lama, and finished at this one. Cool. So this is like the basic thing, and you can like PBS script can give you a lot of stuff.
So if the code that I'm using or the code that I'm trying to understand, if it prints things, I won't see them.
In output file.
I will see them until it finishes, right?
Yes.
Okay.
You won't see them immediately. Don't try to do CV show and all these things.
That's
no shows. Okay. Here like only like you run it. After you finish everything, then you can analyze them.
And if it gives an error, to them, it's gonna stop it, right, or something.
Yeah, it's gonna stop and it's gonna go to error file. Okay. If you have an error, I mean, you can like simulate that, right?
No, it's okay. No, it's okay. Yeah, I understand.
Okay. I think you have errors. Error, inconsistent use of tabs. The Python errors also go there.
Yeah. Okay.
Cool.
Cool.
So this is where you start. If you become advanced, please let me know so that I can learn something. Because I'm not using it yet. So if you keep using it, let me know if you find something cool.
Okay. Well, I thought this was advanced. So what you got into were like bash files, right? And how do you? Is that like Beam? Have you used Beam? BIM?
You can use Vim. You can use Emacs. I use Emacs.
Emacs, okay. And
there's no requirement that you need to use this.
Okay, because I'm not familiar with Beam. Like
Vim is
okay. Okay, sounds good.
So you have Vim, I guess. Let me see.
Don't worry, I can try it.
Yeah, VI should be always be there. VI is a default in Emacs.
Okay.
If Vim is not there, VI should be there. And you can install, I guess, Vim locally.
Okay.
Okay. That's it. And I recorded it actually, so I'm going to